Okay, good day class. All right, so yesterday we have learned 4.7, how to express a complex number in polar form. Okay, and how we can use this polar form to find the multiplication and also division of two complex number by using an easier way. All right, okay, so today we will see how we can use the form of polar form or to solve some other problems. All right, so 4.8 will be, we are going to see how we are going to find power and also roots of complex number in polar form. So means if we can express a complex number in polar form, we can use formula to find the power of this complex number or to find the roots of this complex number. All right, so in this part we are going to use a theorem where we call it De Moivre theorem. All right, so De Moivre theorem say if z is a complex number in polar form, which is r cos theta plus I sin theta, so r is the modulus, theta is the argument, then for all the n are real numbers. All right, so z to the power of n will be equals to r to the power of n, or z to the power of n will be a new complex number where the modulus is r to the power of n and the argument is n multiplied theta, or cos n theta plus I sin n theta. All right, so this is a general formula for power and roots. Later we will see in details or each part. Okay, so this De Moivre's theorem is named after a mathematician called Abraham De Moivre, born in 1667 until 1754. It's about 84 years old. All right. Of a French birth but spent most of his life in London. Means this Abraham born in French but stay most of his life in London. All right. Okay, so today we will see how to use this De Moivre's theorem to find the power of a complex number in polar form. Power means n will be any integer, included positive and negative integers. All right, so let's see how we can get this theorem. Okay, number one. So we have seen that the product of two complex number, just now, okay, yesterday, we have learned that how to find the product of two complex number, right? Z1, Z2. So when we multiply them, so the new complex number is with the modulus R1, R2, and new argument theta 1 plus theta 2. This is for product. Yesterday we have learned this one. Okay, now suppose Z1 and Z2 are the same. Let's say Z1 and Z2 are the same, which is equals to Z. Theta 1 and theta 2 will be the same, no? Let's say equals to theta, and the modulus R1 same as R2, so let's equals it to R. Then you see, this product that we have learned yesterday, this product will become, because Z1 and Z2 are the same, so Z become Z square. R1, R2 are the same, so R square, right? And cos theta 1 plus theta 2, theta 1 and theta 2 also the same, so theta plus theta, 2 theta. All right, so if Z1 and Z2 are the same, so when we multiply them, it becomes Z square, and the formula is R square cos 2 theta plus I sin theta. All right, by repeated use of this product formula, so repeat and repeat again. All right, so you'll find that, let's say we will add one more, Z cube. Z cube, so Z cube is Z square times Z, right? Okay, so the new modulus will be the modulus for Z square multiplied the modulus for Z. Then the argument for Z square multiplied with the argument plus the argument of Z. Right? Therefore, Z cube, this is Z cube, will be equals to R cube cos 3 theta plus I sin 3 theta. Also, we have shown two examples, Z square and Z cube. All right, so this can be repeated n time. You can keep on repeat. Where n is a positive integer, this one for n is a positive integer. Therefore, you will get this conclusion. All right, z to the power of n will equals r to the power of n cos n theta plus I sin n theta. All right, and we call this De Moivre's theorem. All right, so the example that we show here is you are using the positive integer. Okay, so in general, this De Moivre's theorem will be when if z equals to r cos theta plus I sin theta, So for n any positive integer, so z to the power of n, n any integer, positive or negative also can. So z to the power of n will become r to the power of n cos n theta plus sin n theta. Okay, so this is the formula that we are going to use to find the power of a complex number in polar form. It's just that simple. All right. Okay, then use this De Moivre's theorem. We can find the nth power of a complex number by just taking the nth power of the modulus and multiply the argument by n. Means they repeat this one. Okay, so from this De Moivre's theorem, all right, so you see, we get some special statements that we can use in solving our problem. Okay, let's say z is r cos theta plus I sin theta and r equals 1. So this two special for r equals 1 only, is only true when r equals 1. All right, so when r equals 1 and z is in this form, then we will get the statement that z plus 1 over z will become a real number only, 2 cos theta. No imaginary part. Where z minus 1 over z will become 2i sin theta. So z minus 1 over z only left the imaginary part, no real part. Real part is 0. Okay? And from here, we extend and get that z power n plus 1 over z power n will become 2 cos n theta. Also real part only, but n argument become n theta. And zn minus 1 over zn only left imaginary part, which is 2i sin n theta. Later we will see some example in the textbook related to these statements. Okay? Alright, so we will see some examples. Okay, so example 4.8.1. So number 1, we will go through the examples in your textbook. Page 203. We are going to discuss a few examples in this textbooks. Alright, then after that, you will do question 2, which is checkpoint 4.4. You complete question 1 to question 8 as homework. All these questions are related to the power of complex number in polar form. Alright, then you will do question 3 as a quiz. Alright, question 3 will be the quiz, and I will discuss question 4. Alright, okay. Alright, so take out your textbook. Please open to page 20. My textbook is 203. Alright, here. Okay, I'm going to start with example 4.10, 4.10, until 4.15. So these are all the good example in the textbook. So for other part also, please, okay, do read the example in the textbook, to add more info, okay, how to solve the problem other than what we have discussed. Okay. All right, so let's look at the textbook. My one is page 202. My one is page 202. So we are going to see example 4.10. All right, so example 4.10. Okay, maybe I can enlarge it. All right. Okay, so example 4.10. Use De Moivre's theorem. Find 1 plus I to the power of 7. Then they want you to express your answer in Cartesian form. Okay, but to find the power, we know that we need polar form. So the question gives you in Cartesian form, so you express it in polar form. Let's say z is 1 plus I. Alright, so the modulus is 1 plus 1, so square root 2. Okay, and because it is 1 and 1, alright, so it is in first quadrant, 1, 1. So we know that this is pi over 4. So pi over 4, pi modulus. Okay. So actually they try to, I mean this step they try to factorize out lah. No need lah. Actually no need. If we calculate the modulus, we just calculate the modulus. So which is square root 2 and the argument. Argument very simple. Arctangent 1 over 1 pi over 4, right? Okay, so immediately you put in here. Modulus cos pi over 4 plus I sine pi over 4. Alright, so this is z. Express it in polar form first. Then z power 7 means this whole thing power 7. Alright, then just use the De Moivre's theorem. Just use the De Moivre's theorem. So square root 2 also power 7. By right, this. Okay, so square root 2, the modulus, power 7. Alright, then this whole thing also power 7. So square root 2 power 7 means that is square root 2 square then cube. Okay, square cube then is 6. 6 power 6, right? Power 6 then multiply another 1. Power 7. Okay? So square root and square then is 2 lor. 2 to the power of 3 is 8 lah. This is how they get 8 square root 2. Alright? And you know that argument is just multiplied 7. So pi over 4 multiplied 7, power over 4 multiplied 7. Alright? So this is how you express in polar form. Okay? Then after that you calculate. Alright? So 7 over 4 pi is in fourth quadrant already. Okay? It's in fourth quadrant already. 7 over 4 pi. Okay? Because 8 over 4 pi is 2 pi means 1 circle. So this is 7 over 4 pi. And we know that the argument must measure from positive x-axis. So this is 1 over 4 pi. So it's in fourth quadrant. Alright? Therefore, in fourth quadrant, okay, so cos still positive, but sine negative, still not? Alright, so and this one suppose if the question want you to express in polar form, alright, if the question want you to express in polar form, this polar form suppose have to write in, because we always know that the argument is negative 1 over 4 pi, or it must be from negative pi to pi. I sine negative pi over 4. Or suppose if you write it incomplete, it should be like this. And not leave it in this way. Because this one more than pi already. Alright? But because this question, they want us to express the answer in Cartesian form. So it's okay lah. We just press calculator. Alright? So cos negative 1 over 4 pi, same as cos 1 over 4 pi. 1 square root 2. And for sine in fourth quadrant, sine is negative. Alright? Then this one multiply in. Yeah, this is z power 7. 8 minus 8i. Okay? This is this is an easier question, how to use the formula, the De Moivre's formula, the De Moivre's theorem, how to find the power. Okay, so now we go to something more complicated. All right, example 4.11. So you're asking to simplify these two. A is cos theta minus I sine theta power 5. All right, power 5. And we know that, remember one thing, polar form always plus. Why it become minus? It because the anchor is a negative anchor. So I suppose can write this one back into this form. It suppose it's cos negative theta plus I sine negative theta. Power 5 lah. Alright? Then power 4 means that the R is 1. So R power 5 is still 1. Then by using the De Moivre's theorem, so we know that the argument just multiplied with 5. Alright? Then again, cos negative angle same as the cos 5 theta, but sine negative 5 theta same become minus I sine 5 theta. So this is how we simplify it. Alright? Then next, they want you to calculate this one. Simplify this thing. Alright? So to simplify this one, we have two methods. So this is the first method. This is the second method. Okay, first method is, okay, this is the question. So they write 1 in polar form. 1 in polar form means cos 0 plus I sine theta lah. As I sine 0. Cos 0 is 1. This one is 0. Alright? Why they want to write in this form? Because they want to use the quotient formula. This one? Cannot see. Okay, this one. That we have learned yesterday. They want to use this one to multiply it, to divide it. Okay, they want to use this one to divide it. All right. So means that this is your Z1, this is your Z2. All right. Modulus is 1 minus 1 over 1, so 1 lah. Okay, so they didn't write. Okay, whereas the argument, the new argument will be this one minus this one, right? Because it's divide. So the new argument is theta 1 minus theta 2. This is how they get this one. So it becomes negative anchor. So the negative can pull out. All right, so this, after simplified, is like this. Okay, so alternate method is we are using the power of negative n. So this is 1 over this thing, right? So I move this one up. So it's power negative. So just directly use the De Moivre's theorem. Remember we said De Moivre's theorem can use for integer, any integer, positive or negative. So same. So the r is 1 ma, so 1 power negative 1 is still 1 now. Then the n multiplied with the theta. N multiplied with the theta. So you get the same thing. You see, you get the same answer. Alright? Okay, so this is second example. Okay, the third example that they can ask, or the other question that they can ask is like this. Example 4.12. So by using De Moivre's theorem, show that cos 4 theta is equals 8 cos 4 theta minus 8 cos square theta plus 1. It look like it's a trigonometry question, right? Look like it's a trigonometry question. But now we use De Moivre's theorem to do it. Alright? So hence find all the acute angle theta for which cos 4 theta plus 2 cos square theta equals 0. This is later. So means that we are using complex number concept to solve trigonometry equation. Alright, so the solution is, because cos 4 theta is real part only, so we write it like this. We start with a complex number in the form cos 4 theta plus I sin 4 theta, because we want cos 4 theta here. Okay, so we start by using De Moivre's theorem. So cos 4 theta plus I sin 4 theta. So using the formula, so r is 1 lah. When they never write means the r modulus is 1. So 1 to the power of anything also 1. So we ignore it. We don't have to write it. Alright, then this one to the power of 4. It's actually cos theta plus I sin theta to the power of 4. Because after power 4, it becomes 4 theta, right? Alright, then we are using binomial theorem. Okay, remember binomial theorem? To expand this one to the power of 4. Also, remember, first term, power 4. The last term, also power 4. Sin theta, also I sin theta, power 4. See that? Second term is 4c1. 4c1. Then, the first term power decrease, become 3. The first term, the second term increase, sorry. Then the third term is 4c2. Then decrease again, cos theta decrease again, become square. I sin theta increase again, become square. And the fourth one will be 4c3 cos theta, and the I sin theta, the power increase until power 4. See, this one is using binomial theorem that you learn in second chapter to expand it. Alright, so now we're equating the real part. Real part means cos 4 theta lah. Okay, and real part is here lah. This is real part. Cos 4 theta. This is also real part. Why real part? Because I square is negative 1. So no more I. So my I square is negative 1. So this is also real part. And the last one also real part. Because I power 4. I power 4 is positive 1. We only take the real term. Alright. So after that, this one copy. So 4c2 is 6. Alright. So I square is minus 1. Okay. So this one is sine power 4. Sine square. Sine power 4. So they are using the concept sine square theta equals 1 minus cos square theta. Alright. And power square. So power 4 lah. And I power 4 is positive 1. Alright. Okay. So after that, they continue. Okay, so they continue. So the sine square, they change to 1 minus cos square. Okay, this one just now we have done. They expand it only. They expand the quadratic only. All right, then after you rearrange everything, you get 8 cos power 4 lah, because minus 6 cos square multiplied cos square 6 cos power 4. So plus 1, so plus 8. All right, and power square you also have 8. Here minus 6, here minus 2, so minus 8. All right, and then after that plus 1. This is how we prove it. All right, then the next one, they wanted to solve the equation. All right, they want us to find the acute angle of theta, of this equation. All right, so the cos 4 theta we substitute with this thing. This is cos 4 theta, right? Okay, so the cos 4 theta we substitute with what we have proved, plus 2 cos square theta. All right, then just simplify. Minus 8 plus 2 minus 6 plus 1. Then factorize them, like we solve trigonometry equation. Or factorize them. Then you find that for this part, your cos theta is plus minus 1 over 2. Okay, for this part, your cos is plus minus 1 over square root 2. All right, so remember the question wants us to find acute angle only. Acute angle only. All right, so for this one, plus minus is just to show which quadrant in all the 4 quadrant, but we only want acute angle, means only in quadrant 1. So when cos theta equals half is pi over 3, 60 degree. When cos theta equals 1 over square root 2 is 45 degree, pi over 4. So we only want the answer in first quadrant. All right, because the question want acute angle only. All right, okay, so this is how we can use this De Moivre's theorem. All right, okay, next, remember this statement that we have discussed just now? The z power n plus 1 over z power n and z power n minus 1 over z power n. All right, so you see, let's say z is this one. Remember we say that for these two theorem, the r must be equals 1. For these two only, r must be equals 1, then only can do. All right, so let's say z is this one. So z power n by using De Moivre's theorem. All right, so z power n means this one power n, so just argument multiplied with n. So 1 over z power n means I shift the power n to up. So shift the power n up means it's minus n, power minus n. So the argument multiplied with negative n. So because negative angle, this one become minus . All right, so I have zn and 1 over z power n. Zn plus 1 over z power n means this is zn, this is z 1 over z power n. So this one plus this one. So you see or not? I sine n theta minus I sine n theta, no more. So left 2 cos n theta only . All right. If minus them means cos n theta minus cos n theta, no more. I sine minus negative minus this one, so plus, so become this. All right, so this part show how we get these two statement, or how we get these two statement, this one and this one. All right, okay, so now we will see some example which related to these two. Sorry, cannot see. All right, sorry. Here. Correct, right? Okay, correct. So we have how we can use these two statement. Okay, so let's see example 4.13. All right, example 4.13. Smaller a bit so you can see the whole question. Okay, example 4.13. If z equals cos theta plus I sine theta, whereas sine half theta is not 0 so prove this thing. Prove z plus 1, z minus 1 is equals to negative I cotangent half theta. Alright, so first thing, we multiply the denominator, alright, and the numerator by 1 over z minus 1. Okay, so z plus 1, z minus 1 multiplied with this thing. Later you see why we want to multiply this one. So multiply just z multiplied 1 over z, so it's 1 minus z. This one plus 1 over z, this one minus 1. Alright, so 1 minus 1, 0. So left z minus 1 over z. They multiplied this one because they want to create this thing. This one. Because they want to create this one. This term. So that we can use the formula. Okay, so do the denominator. So denominator also the same. After you expand, you get z plus 1 over 2, but minus 2 here. Because here is 1 plus 1. Alright, so z minus 1 over, so z minus 1 over z, power 1, so it's 2i sine theta lo. The minus 1 is sine, right? And the plus 1 is 2 cos theta lo. Alright, the n is 1 ma. Okay, minus 2. Alright, so 2i sine theta, they use the, for this 2i sine theta, they use the half angle formulae. Okay, I hope you still remember the half angle formulae. Okay, sine theta is 2 sine theta over 2 cos theta over 2. This one also, 2 cos theta minus 2, we factorize out 2, become cos theta minus 1. So cos theta minus 1, the cos, use the cos 2a. Half angle formula, you get this thing. You can refer to the trigonometry part to find the half angle formulae. Alright, so 2 and 2 simplified, left I. Because negative, so negative I. So sine theta over 2, sine theta over 2 can simplify 1 because this is square ma. Alright, so left one is cos over sine. Cos over sine is cotangent. Okay, so this is how they use these two statements. Alright, so one more example. Okay, one more example, 2. Okay, example 4.14. Okay, example 4.14. Okay, so show that cos cube theta sine theta is equals to this thing. Alright, so we start with, because we know that we want cos cube theta. Alright, and we already know that, hold on, we already know that, yeah, we already proved that, can see, okay, here. Okay, we already proved that z power n plus 1 over z, power n, power n, plus 1 over z power n is equals to 2 cos n theta. We have proved this one. So because I want to use this, so I start with 2 cos theta, the whole thing cube sine theta. Even though I know that my question is only need cos cube lah. So we add in the 2 first. Alright, so 2 cube is 8 lah. So this is cube, cos cube theta sine theta. Alright, so we know that 2 cos theta just now, 2 cos theta is z plus 1 over z lah, because n is 1 ma. Alright, 2 cos theta is z plus 1 over z, so cube. Alright, where else? Sine theta is here. Can see or not? Can see. Okay. This one. Alright, zn minus 1 over zn is 2i sine n theta. So n is 1 now. Alright, so this sine theta, sine theta, sine theta. So I shift the 2i to this side. So it's 1 over 2i, z minus 1 over z. The 2i shifted to this side. Okay, so you get this thing. Alright, so this 1 over 2i, I put it here. So I'm going to multiply these two things. Let me see. Okay, 1 over 2i, we put it here. Okay, how it become like this? Okay, how it become from here, how to become like this thing? Because you see, at first we are cube. Alright, now become square, you see? So where is another one go? I write here. So another one is z plus 1 over z multiplied with z minus 1 over z. See or not? So the square, they put it here. So left another 1 multiplied with this thing. Okay, so you get z squared. This is conjugate, right? Z plus 1 over z, z minus 1 over z is conjugate. Remember? Conjugate. So z squared. But this one minus lah, because no I, so no I. So it's minus. This one multiplied, this one is 1 over z squared. Okay? Other than that, plus minus, no more. Alright? So left this thing. See? So this is how they get this one. Alright. Then we expand this square. Multiply with this thing. Okay. Then this one multiply with this, so you get this. This one multiply with this, you get this. So 2 multiply this one, you get this thing. Alright, then this one again conjugate, right? Conjugate. So z power 4 and 1 over z power 4. The number will be eliminated. So this one is 2 z square minus 1 over z square. Here is 2i sine theta. So 2i sine 2 theta. Multiply with this 2. Multiply with this 2, so become 4 lah. Okay, this one is like this. So this one is 2i sine 4 theta lo. This one. Okay, so multiply in, you get sine 4 theta plus 2 sine 2 theta. So move the 8 to this side. So this is what we shown. Alright, so you can read it carefully. Or you can read it carefully at home. Read it again. Alright, what else? Example 4.15. You are given complex number z. Find argument, find modulus and argument, no problem. Use De Moivre's theorem, show the power. Yesterday we have learned. Just use a formula. Then C, express z power 4 and conjugate z in the form of x plus yy. Alright, so this one no problem. It's quite simple. So I want you to read this example on your own. Because later, later I'm going to discuss one past year question, right? It will be something like this. Okay? So please read yourself. Example 4.15. Alright? Okay. So now, okay, smaller it. Alright. Okay, so now what we are going to do is, we have finished this one. Okay, so remember, question 3 will be your quiz. Alright, so I will discuss question 4, which is a past year question. STPM 2016. Alright, so you see, the complex number z and w given like this. So z is minus 1 minus I. W is 1 plus I square root 3. Alright, then they want you to express z and w in polar form. Alright, so 5 marks. So after that, express complex number z power 9 over w power 4 in the polar form. Alright, where r should be positive and theta is negative pi to pi. This part 4 marks. Alright, so let's see how we can do it. Okay, you can see, Alright. Okay. This one cannot see. Can see? This one cannot see. We make it smaller. Okay. Now can see the whole solution. Okay. Alright. Okay, so STPM 2016. This one here. So example 4.8.1, question 4, STPM 2016. So you are given z. Z is minus 1 minus I. So modulus is 1 square plus 1 square, square root 2 lah. And argument is arctangent, y over x, minus 1 over minus 1. Okay, remember to draw the eigen diagram. So x negative 1, y negative 1 is in third quadrant. So we know that the argument should be negative. Alright, so 1 over 1, arctangent 1 is actually pi over 4. Pi over 4, alright? But because of this diagram, you know that this is pi over 4, so this is 3 over 4 pi lah. Minus 3 over 4 pi. Okay, this is pi over 4. So this is 3 over 4 pi lah, but negative lah. Alright, argument. So z in polar form will be square root 2. cos negative 3 over 4 pi plus I sine 3 negative 3 over 4 pi. You can stop here because later we need to use this one. Or if you want to write it in this form also can, cos 3 over 4 pi minus, because sine negative theta is negative, sine theta also can. You can write in this way. But for part B later, when we use the polar form to find the power, we are going to use this original one. We must use the original one. We cannot use this one. Alright? Okay, for W is 1 plus I square root 3. So modulus is 1 square plus square root 3 square. So it's 4. Alright, so square root 4 is 2 lah. So modulus is 2. So argument is arctangent y over x, square root 3 over 1. So x is 1, y is square root 3 is in first quadrant. So positive angle. Alright, so arctangent square root 3 is actually 60 degree. So 60 degree is pi over 3. Alright, so W in polar form will be 2 cos pi over 3 plus I sine pi over 3. Alright, okay. Now, we go to the second part. They want us to express this one in polar form. Z power 9 over W power 8. Alright, Z power 9, W over 8. Okay, so this is Z. This is a Z. Remember, we use back the original one. We don't use this one, original one. So, modulus, also power 9. Alright, then the anchor multiplied with 9. When multiplied with 9, negative 3 over 4 multiplied with 9 is negative 27 over 4 lah. So here also the same. Okay, this is Z power 9. And W power 8. So this is W. So modulus also power 8. Then anchors multiplied with 8. Alright, so in fraction form. Okay, now we will see how we are going to simplify it. Alright? So square root 2 power 9 I can write as square root 2 power 8. Square root 2 power 8 is actually 2 power 4 lah. So left one. Alright, 2 power 8 is still 2 power 8. Okay, then next is we are using the concept of division. Remember, when we divide two complex number, we just minus the anchor. Remember, the argument is minus. So this one minus this one. Negative 27 over 4 pi minus 8 over 3 pi. Plus I sine also the same. We minus the argument. Modulus divide modulus, argument minus argument. Remember, to find the division of two complex number in polar form. That we have learned yesterday, this one. Alright? Okay, this one not enough space, so I write in 2 rows. So this one after simplified, 4 and 8 can be simplified lah, become 2 power 4. So 2 power 4 is 16. Square root 2, 16 lah. Okay. Then see this one. So negative 27 over 4 pi minus 8 over 3 pi. Or you can use a calculator and you get negative 113 over 12 pi. The argument is negative 113 over 2 pi. Alright. So how we, because we know that, just now we already say the argument should be in negative pi and pi. Cannot more than pi. Or cannot less than negative pi, right? So how we know that negative 113 over 12 pi is actually same as 7 pi over 12? How we know this? Alright, so let's look at this diagram. Let's look at this diagram. I hope you can see. Okay, I hope you can see this diagram. Alright, so negative 113 over 12 pi. Negative 113 over 12 pi, when you press calculator, is negative 9 over 5 over 12 pi. 9 pi. Alright? So how we get this thing? So we start from, remember, we start from negative negative angle, so start from here lor. So this is negative 2 pi. Okay, one round negative 2 pi. Alright, then one more round negative 4 pi. Okay, negative 2 pi. Then one more round negative 4 pi. Can I show you in a better way. So negative 2 pi. Alright, then continue one more round here, negative 4 pi. Alright, then continue one more round. Here is negative 6 pi. Alright, then one more round. is negative 8 pi. Until here is negative 8 pi. Alright, but we have negative 9 pi. So negative 8 pi, add one more negative pi, so negative 9 pi here. Negative 9 pi here. Negative 9, 5 over 12. So continue another 5 over 12. So this is negative 9, 5 over 12 pi until here in second quadrant. Alright? But we know that our angle, again, like just now what we say, it must be in between negative pi and pi. Okay? So it means that the argument for this new complex number, suppose from 0 to this line. Can see? Okay, cannot see. It's supposed, this is a line, so it's supposed from 0 to this line. So this is the argument for the new complex number. Alright? So here is, just now we say, right, here is 5 over 12 pi. So from here to here, 12 over 12, 12 over 12 minus 5 over 12. So 7 over 12 pi lah. Alright? So this is the new argument. This is how we get this thing. So it's a little bit complicated lah. I don't know whether you use calculator can help you to get this answer or not. Alright? But this is the concept how we get this thing. Okay, so again, negative 113 over 12 pi is actually negative 9 over 5 over 12 pi. So negative 9 pi. So start from negative 1, 2, or one round is 2 pi, 4, 6, 8. Alright, negative 8. So add one more, negative 9. Okay, and another 5 over 12. So negative 9, 5 over 12. So if this is 5 over 12, then this is 7 over 12 lah, pi. Alright, this is how we get this new anchor. Alright, so this is the answer. So from here until here, 4 marks. 4 marks, right? So this is a complicated part lah, how to get this thing. Okay? So this one you can leave it here because cert is on numerator is okay. Alright? So this is question 4. STPM 2016. Alright? So this one also, this one, just now I asked you to do this question. Where is it? This question 2013 as quiz, right? You are given Z. You are given Z. So find argument, find modulus and argument. Then use De Moivre's theorem. Show that Z power 5. So use this, just use the formula. Z power 5. Answer given. You must get this answer. Then C is express Z power 4 over Z star in the form X plus YI. Means something like this. You use De Moivre's rules to find Z power 4. Alright, not this one, this is Z power 5. Z power 4. Then Z star is conjugate, right? Conjugate of Z. Alright? So you need to use the De Moivre's law on this part only. This is a conjugate. But you can use the division concept. Use the division concept to find the new one. But be careful with the anchor. This is okay. This is better. Because after you get this thing, you can actually just use a calculator to calculate the number. Because they want it in Cartesian form. For your 2013, they want Cartesian form. This one, they want polar form, right? This one, they ask for polar form. Okay, so today's lesson, I will stop here. So please complete your quiz. Only one question. All right, then put it into the Google Drive. All right, then you prepare for the last lesson. Okay? All right, thank you, class.